Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students at Illinois State University, please go to smarturl.it/help-ISU-actuary. This is a practice problem for exam P on probability. A certain brand of refrigerator has a useful life that is normally distributed with mean 10 years and standard deviation 3 years. The useful lives of these refrigerators are independent. Calculate the probability that the total useful life of two randomly selected refrigerators will exceed 1.9 times the useful life of a third randomly selected refrigerator. Well, let us denote the lifetimes of the first two refrigerators by X and Y, and the lifetime of the third one by W. We are looking for the probability that X plus Y is greater than 1.9 W, which is the same as probability that X plus Y minus 1.9 W is greater than 0. So let us write V for X plus Y minus 1.9 W. Then V is a linear combination of three independent normal random variables, so it is normal, and its mean is the mean of X plus the mean of Y minus 1.9 times the mean of W. But X, Y, and W come from the same probability distribution with mean 10, so we plug in that 10 for the mean, and we get 10 plus 10 minus 1.9 times 10, so 20 minus 19, and that's 1. And the variance of this linear combination, because X and Y and W are independent, that also means that X, Y, and 1.9 W are independent, then the variance of a sum, actually a difference in this case, but it's a sum with one of the linear combination sum type of normal random variables that are independent, so the variance is the sum of the variances of individual pieces. Their covariance is a 0 because they're independent. So it's a variance of X plus variance of Y plus 1.9 squared times variance of W. Now, of course, you know that this negative sign in front of 1.9 doesn't matter, because what we're really taking here is negative 1.9 squared, which is the same as 1.9 squared. So this is 9 plus 1.9 squared times 9, and that's 50.49, with the resulting standard deviation of the square root of 50.49, which is approximately 7.105,63157. Then the probability we're looking for is the probability that, effectively the probability that V is greater than 0, which is the same as probability of V minus E of V over sigma V being greater than 0 minus E of V divided by sigma V. So now this V of E of V over sigma V, that's a normal random variable standardized, so it is standard normal. So we write Z for a standard normal random variable, and this becomes the probability of Z greater than 0 minus 1 divided by 7.105,631.63157. So 7 point, and then all this long piece here there. Well, eventually we're going to take this to be 1 over that 7 point and so on, and find the reciprocal. But for now, we write this as 1 minus Z being less than or equal to that number. Notice that that number is really negative 1 divided by 7 point and so on. So it's 1 minus the phi, the CDF of the standard normal distribution, evaluated at negative number 1 over 7.10563,157, and phi of minus a number, so phi over some negative number, is the same as 1 minus phi of the positive version of that number. So this phi of negative 1 over 7.10563.157 is the same as phi of 1 over 1 minus phi of 1 over 7.1563157. So the ones cancel and we end up with simply phi of that number, the positive version. And 1 divided by that 7.1 and so on is approximately 0.14073344, and we either look it up in the table or use the normal distribution evaluator, the software that evaluates a normal distribution that you get on the real test, and this is approximately 0.555959974, well, almost 0.56, which is answer C. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries, is reproduced with permission, but the solution is mine. Good luck in your studies and good luck on the test.